Engineering 305, FEA Beam problem. And another thing, don't you always hate it when you go, oh, you know, if I had only done... Well, as I finished up the video last night, it was pretty short. I didn't want to make it, but there was some questions from people that, you know, we addressed. So the problem that we had last night was I ran a quick analysis that looked like this, and I calculated displacement, and I got 5.35 millimeters. And if you recall, it gave me a warning about large displacement, and I said, no, we're not going to do that. It just takes longer. It does. It takes longer. So I did this. I calculated 5.35, and then I said, well, but what you really need is to have that floating end so that it can shrink. And I put the floating end on, and I ran the analysis, and I saved every one of my, you can see I got 4 different types of analysis down here. And I just kept them all, and I got effectively the same number, 5.387. What did I have, 5.35 last time? 5.387, and this is, come on, 5.385. I mean, that's the same number. So what was going on, and why didn't it, well, it was because I checked that large displacement box. What happens is, it calculates, the software calculates the stiffness of the beam initially when it's flat and horizontal. Once it starts to deflect, then it starts to pull and the tension force comes in. When you're loading it this way, there isn't any stiffness this way. So until I start having it change shape and stretch, it doesn't think of it as having any stiffness. So I went back and I hit the string, which was the small deflection. Here's, I don't know if you can see the labels at the bottom. Here's the string large deflection. And then I ran the displacement, and now I got 3.4 millimeters compared to the 5.8. Compared to the 5.8 that I get here. So now, 5.3, sorry. So now you're really seeing 3 different values. One is, if I simply checking a little box under here, under properties, check the large displacement box, and that changes our answer. So then you say I got the small displacement, and I did this beam one with a floating end and small displacement. Well, let's go back and check the large displacement, because that tension force may have some value. Remember, oh, you know what? Let's double check this. This was 5.387, right? So it's the same as the small deflection of the string. And I haven't run this yet. Properties. Good thing these are short. All right, run this study. Ding. Actually, that's not quite done. It's setting it up. It's doing iterations. And once it solves part of it, then it has to change the stiffness matrix. It has to set the equations up again. Okay, 5.386. Pretty much the same answer, because, you know, we did put that on a roller, so it was able to come in. And now I bet if we looked at our displacement in the z direction, it's all going to be in one direction. Yep, it's all in one direction. It's all moving. Let's see, it's moving in the minus z. No? Oh, yeah, because I built this model backward. Here's my fixed end over here. And then this is sliding forward. So, and then I go back to, if we build it with the pivots the way that I wanted to build it, I get a deflection which is much higher. I get a deflection of 21 millimeters. So 3 different values depending on, and just small changes to the end conditions, and then another, change it by 40% just by going from checking a little box, which we don't even, I'm not even going to teach you what that really does. I mean, I talked about it briefly in the video, but there's a lot of stuff to know here, and we treat this like a black box, but there are things that maybe should scare you a little bit that I don't necessarily always get the right answer, unless you've built up experience and start understanding what those things are. So, all right, there you go. And another thing. See, I told you there's always more to come.